Hey, how you guys doing?
Good.
Thanks for coming out. I wanted to give this talk purely because it was fun to do, to make this little thing. I didn't realize, as you'll find out, I didn't realize you could actually do this with lambda and Python. So I figured to serve up HTML, you had to do some other stuff. But AWS actually provides you a method to do this purely in Python, which is, well, it's not purely in Python. You still have to write some JavaScript, which totally sucks. I'm sure there's easier ways to do that. I picked the hardest way. Don't judge my code. You'll see it later. It works. That's all that matters. Some of you know me. I'm the director of cloud infrastructure at IronNet. I do get to write code still. In fact, I had a couple of PRs today, so I still get to do code. It's very rare. It sucks. The code part, not the writing code part. Not writing code sucks. That's what I meant to say. Our AWS account manager likes me a lot. We spend a lot of money on Amazon. Not nearly as much as other people, but I am liked at least by one person, even though he's paid to like me. I like data. We were kind of just joking earlier about NLP and pushing data through things, but you'll see here I've been collecting this airplane data since 2018, and it's a lot of data. It's a big data problem, even though it's only like 50 gigabytes of data now. It's big data is what you make of it. 50 gigabytes of compressed JSON is a big data problem. But yeah, like I said, collecting it since 2018. You'll see it's a weird data set. I like it. And I love some AWS, and that's why I'm here. So I think I wanted to start. I know we kind of already figured out that a lot of us already know what serverless is, but I wanted to clearly define serverless versus serverless. There is obviously Lambda, Microsoft functions, or whatever it's called, Google's functions. That is the idea that you can provide, using somebody else's computer, on-demand processing to the microsecond, essentially. You pay, a couple of micro pennies per invocation. That's serverless. When you're not using it, it doesn't cost you any money. The other serverless term you'll hear in this is actually the Serverless Framework, which is what I use to actually deploy this. It's just an open source framework that a lot of people use. There's a lot of different frameworks that you can use. I forget all the different ones out there. I think even AWS has a mechanism to do it through CDK. There's a whole slew of ways to do it. You can even manually deploy it out there yourself if you create the zip file properly and push it to Amazon. Serverless makes it a little bit easier because you'll get to actually, I can create other important parts, not just the actual function itself. There's other parts to it that you need to include to make it work properly. Included this purely because I think what you'll see here is there's clearly the way that you would display static HTML via something like S3 or CloudFront. You can put static resources in GitHub. There's just serving it through a web server. Apache Nginx, just putting those files there, you can serve it out there. Obviously dynamic generated HTML. Django is obviously the one we all love here. Other server-side rendering HTML, who cares about that stuff? We're actually talking about the way we're doing it today. We're going to dynamically generate some HTML with Python for almost free. So I wanted to kind of show why this whole thing is set up the way it is. I have this Raspberry Pi. I'll talk about it here in a second. I have this Raspberry Pi at my house that is collecting this airplane data with a radio receiver listening on 1090 megahertz. It presents the data that I want to look at in a really nice format. Problem is, if I wanted to see that data outside of my house, I'd have to expose my Raspberry Pi through the firewall. I'm not an idiot. I'm not going to do that because there are mean people out there that can mess with it, and I don't want them to do that. So since 2018, I've had a little piece of Python code running on that Raspberry Pi that listens to a web endpoint on the actual Raspberry Pi, and it just every 30 seconds sends the complete JSON list of aircraft to S3. And I just did stuff with it. I'd throw it into Athena, I'd query things. At one point I got bored, I took it all and I threw it into Elasticsearch, did a heat map and found out that I had actually, with my Raspberry Pi sitting in my house, I had picked up aircraft all the way up in Ottawa and all the way down in Georgia for like a split second. You'd look at it and like the heat map over the DC area was like hundreds of millions of collections. Down in Georgia, one. So the radio wave had bounced just ever so perfectly at one split second that I picked up that aircraft all the way down there and all the way up in Ottawa. Fascinating. Just had to bounce just right and it got picked up. So it's cool. Like the data is really interesting because you find out that you can actually get the curvature of the Earth just right and pick up this plane in Ottawa. Like, where the heck that come from? It's probably one of those aliens we were talking about before. Broadcasting ADSB. I'll talk about it here in a second. That when I actually show the Raspberry Pi side of this, it's just a frequency protocol that airplanes broadcast. We'll get to that in a second. On the other side, because I didn't want to expose the Raspberry Pi, I said, okay, let's actually build a mechanism by which I can view this data. It's not as pretty as the way that it gets displayed through the Raspberry Pi. Again, you could make it pretty. We'd need a web designer and some smart people with Django to do that. In my case, I just wanted to pull the data out of S3 and then format it to make it look a little pretty and serve it out. When I found out that you could use Lambda and API Gateway to serve that HTML, I said, hey, that's great. I don't have to build a web server. I don't have to serve up the content. It actually just has the actual Lambda. When you hit the API Gateway endpoint, the Lambda actually reaches into the bucket, pulls the information that we need. As you'll find out, I'm actually just pulling the last 90 seconds worth, so three objects worth of data, and it just serves it out. Like it's a fairly simple, it's actually one of the simplest AWS environments that I've ever seen. It's really only like 3 resources. Pretty simple. Nice thing is the actual cost, super cheap, $2 a month, $31 a year. That's actually all S3 costs. The Lambda and API Gateway doesn't even register on my bill. It's still within the free tier because it's only the amount of times that I hit it. Now, if this goes viral on YouTube and somebody hits that endpoint, it's still only going to cost me like $10 because you get like 100 million invocations for nothing. So have at it, people that are watching this on YouTube. I'll post the link later. Hit it all day long. I don't care. It's not going to cost me a dime. Because really, just the biggest part of it is the storage. And I could even probably optimize that and say, like, if it's past a certain age, put it in infrequent access, and then the cost will even drop lower than that. So it's pretty good. Any questions on that so far? Sweet. So I know this says demo. I want to actually pull up the actual article I wrote initially on this back in April of 2018. So this is the Raspberry Pi. It's just a Raspberry Pi. That's all it is. It's running PiAware, so it's a version of Linux distro that runs on Raspberry Pis. It's created by the company FlightAware, or the organization FlightAware. All this stuff you'll see here is all from FlightAware because what they want is they want these devices out there sending data to them, and then they correlate that, or they condense all that data, and then they sell it to like Google and all the other companies that when you look for flight information, they're all getting it from these things. So it's like 20,000 Raspberry Pis distributed all throughout the world are providing Google, and truthfully, I think it's even like Delta and all the other airlines, they all get this data from idiots like me putting these Raspberry Pis in their house. So it was a little $35 Raspberry Pi. little dongle. That blue one on the left is the actual software-defined radio, but it's only tuned to 1090 megahertz. So you can have a software-defined radio that like picks anywhere from 30 megahertz all the way up to 1.6 gigahertz, and then you can tune it. There's another talk on the Python Frederick, or actually your Matt Lehman, your YouTube for my ADS, or not my ADS, be my just too many acronyms, way too many acronyms in this stuff. Software-defined radio talk on Python Frederick, kind of talks about just a software-defined radio. This is specifically tuned to the 1090 megahertz, which is the ADS-B frequency that all these airplanes are broadcasting, and they all are required now as of 2020. They all have to broadcast it. If you're a commercial plane, you have to broadcast this frequency, and it includes a whole slew of information I'll get to here in a second. The little circular thing on the right-hand side is just a filter. So the stick, the software-defined radio is only tuned to pick up 1090 megahertz, but if you put an actual hardware filter in there, it'll actually clean up the frequency, and it just increases the range at which your device can pick up. And then lastly, I have a 1090 megahertz tuned antenna mounted to the chicken coop that's just ever so slightly above my roof line. So it's close enough to the house so that if it gets struck by lightning, the house will get struck by lightning, not the antenna, because the house is insured, not the antenna. But it's high enough so that I can actually pick up all of the airplanes in a huge area. I mean, you'll see here in a second. This is, I don't remember what time I took this at, but this was back in 2018 when I took it. I don't know what time of day, but hundreds of airplanes overhead. You get all the way down to, on an average day, I'm picking all the way up down to Newport News, Richmond, all the way up into Scranton. Usually I can pick up planes landing into JFK and Newark. They drop out at around like 30,000 feet, but I can see flying into Dulles at 2,000 feet. There was even one time I saw a plane at Dulles on my machine on the view. It was at ground level, so it was broadcasting ADS-B on the ground, but at such it was probably a massive plane just with like a bunch of broadcast capability, and I was picking it up.
Is color altitude?
Yeah, so all the purple ones are around 40,000 feet. The greenish ones, the yellowish ones are 30,000 and 20,000. Yeah.
Fun. Is this part of the FlightAware
Yeah.
distribution?
So it actually has a UI that you go to the IP address of the Raspberry Pi /SkyAware. They actually updated it because now, this is an old picture. I should have taken a new picture. It'll show weather data and flight maps and all that now. I don't even go to Weather Underground anymore for like the radar. Like today, the weather that came in, I quickly just go to the Raspberry Pi and I can see the incoming weather. It's not, the Raspberry Pi is not picking up the weather. It's pulling the weather from Weather Underground or some other open source location. But it's a great view because it like centers right over top of my house. I don't have to go to Weather Underground, click on Frederick, pull up the NextRad radar. I can just go to the IP address that's on my machine and pull it up, and it's there. I got the weather data, right?
Can you see planes like avoiding weather patterns?
Today, yeah, totally. I should have screenshotted it, and I closed it out. But when I pulled up the weather, the actual front that was coming in, there was the front that was directly over top of Frederick, and right behind it, in between us and like Hagerstown. See where those planes are going? There was a little bit of space, and they were all skirting through there to get down to Dulles. It was crazy, and you could see them going up around Hagerstown to come down the same line. Pretty interesting. All right, Yeah, it's super simple. It's just Raspberry Pi. Anyways, so I started, this is basically the Python script that I wrote. I definitely want to refactor this someday because I'm like passing in access keys and secrets. Like they're hard coded into the Python script. It's on the Raspberry Pi. I don't care. I should do it better. Environment variables or an actual like config file. Again, this was 2018. This is like 5 years ago. This is when I was a little baby Python kid, right? I don't even think Python Frederick existed yet, so don't judge. Anyways, so it just pulls the data and kicks it off to S3. Very simple. And it just loops, and every 30 seconds it just pushes it up there. So that's really all that is. You can see that it's been doing that for a long time. So long, in fact, that actually it also does one other thing. Not only does it push to S3, I also publish a CloudWatch metric. So it'll actually keeps track of all the airplanes, like the maximum count. Those gaps are, I got lazy and I forgot to make sure that it was still running. For like multiple months it would happen. It would just break and I'd forget to check it. Surprisingly, when you set up a CloudWatch alarm to send you an email when the metric stops reporting, it motivates you to go fix it. Back when COVID was big, I don't know that I have that data anymore because I think it maxes out at 15 months. But when COVID was really bad, it dropped super low, like down in the 50s on a daily basis because no planes were flying. It was crazy. But now we're back up. There's tons of airplanes overhead. We can actually zoom in to the last 3 hours, I think. Oh, I need to change the time period. Let's go 15 minutes. Yeah, so like right overhead right now, there's 148 planes overhead. That's cool. Anyways, we're talking about how do I get this information out of my house so that you guys can see it. I think that's the next part I wanted to get to. Yeah, like I said, 50.2 gigabytes of JSON data, and actually,
a single snapshot.
It's almost like I paid you to ask that question.
I mean, I guess it depends on the number of planes in the air, but
Yeah, it's entirely dependent on the number of planes. Here is one that I wanted to look at. Give me a second. It's okay, this can get broadcasted purely because they're only short-term, short-lived credentials. Cool, all right, I'm in there. Let's take a look at this one. So this command, I just pulled the JSON in one of the records from yesterday from the S3 bucket and passed it through JQ, and this is what it looks like. This is a single entry here. Actually, let's go ahead and helps if I can spell aircraft. I'm so lazy, I'm just pulling it multiple times. Let's get it actually, oh, come on. There we go. So remember, Director of Cloud Infrastructure. I do write code, just not much. I think it starts with, oh geez, I forgot about that, hold on. Yeah, aircraft. I knew it was something like that, I just spelt it wrong. There we go, all right. So this is just one entry. Well, I guess I didn't do it. Helps if I do. There, first entry. So it's not always the same size. It's JSON. Sometimes you get some information. Like in this particular case, I think it means it was seen 0.6 seconds ago, I think. The hexadecimal there is actually a unique identifier that the aircraft actually broadcasts. RSSI is the signal to it, which is a radio thing that I used to know what RSSI stood, but I think the lower the number, the better the signal. And then the number of messages. That's not a very good one. Let's pick randomly 10. There we go. So this is flight AWI 3843. We can actually go to FlightAware. And because I broadcast this, or because I pick up this data for them, I get an enterprise user account. So I can get a whole bunch of cool information. But that is actually Air Wisconsin 3843. And it is somewhere.
When's the log from that you just pulled?
It's actually hasn't taken off yet. So I guess I'm picking it up from the ground. That's weird. Maybe. Oh, you know what? So FlightAware delays the data because they don't want bad guys using that information. I forgot. They delay it like 5 to 10 minutes. So I'm probably picking this up. What's the altitude? Yeah, 7,000 feet. It just took off.
That's pretty cool.
It just took off. FlightAware it's supposed to have taken off here. Well, it says it got delayed. That's the problem. It was scheduled to take off at 6:10 p.m. So it had taken off. FlightAware is not showing that it had taken off yet because the data is delayed. But my Raspberry Pi has picked up that data. So it provides other things like latitude and longitude. Like I said, that hexadecimal, you can actually look up that hex and it reports to the actual aircraft. Whole bunch of other stuff. The direction that it's going, occasionally it'll show that. Whole bunch of other information. It's all very useful if you're building a application to display this data, as you'll see here in a little bit.
All right, is there a way you can get a count of the number of planes from that?
Yeah.
I don't know the JQ query that would do that.
I think it actually is retained at the end of the. No, that's total messages. I think it's. I think it's. You can count it somehow.
Can
Hold
you
on.
close the quote after the aircraft when fighting the count?
It's actually a.
WC or
You could do word count. Yeah, I think that'll count because JQ is gonna print it out. JQ has a count. We'll just use it. I just need to remember what it is. Length? Oh, yeah. Well, that didn't work. I could hold on. I could tell you here. It's 148
All right, cool.
because that Python script that's pushing 2S3. I am counting the length of that array of that list, and I post that to CloudWatch.
Yeah. What if you pipe the file or push it through DU? What's the disk size on it?
$59 kilobytes.
Okay. We got 50 gigs worth of
Uh-huh.
59 kilobyte little files.
Uh-huh. Every 30 seconds.
Sweet.
Yeah. There's a lot of data. Takes a long time to push that through stuff. When I pushed it to Elasticsearch, I had to, because it was all in S3, and I think at the time there wasn't a mechanism to like set up an automatic message. You couldn't, I don't think you can either now. you can't say, take this entire bucket and create SQS messages to then process through Lambda. I had to identify all of the objects in the bucket, create SQS messages, I pushed them to Lambda, and then Lambda would take that data and throw it into the Elasticsearch cluster I'd created. That was the only way I could have processed all of that data in any semblance of time, because if I had just set up a single client to like read through all the buckets, all the bucket data would have taken like 6 weeks. And so I used Lambda. Again, I haven't found a perfect use case for Lambda yet, aside from like one-offs of, oh, I want to process 50 gigabytes of compressed JSON. Let's do it concurrent times 1,000 lambdas and have it pick up off an SQS queue and send to Elasticsearch. That worked out great. It only took 3 hours. That did cost me like $100 though. After the fact, I was like, oh man, probably should have rethought that. But it's okay. All right, so we got the data that's coming out, right? Because we want that data. So I said, hey, let's build this. This is actually the script that dumps the data. We don't want that. We don't care about that. We want to actually look at the data that's coming in to actually view it. So let's actually take a look at this here. So serverless is great because you can just run like serverless init or whatever it is to create like a base project. You can say, hey, I want to do Python. It'll create the Lambda handler. It'll create the serverless YAML. And then you write your code, right? Again, don't stare too deeply at the code because you're going to be like, wow, this is stupid. I agree. It gets the job done though. So ultimately what we're doing is we say, we need a lot of imports. The imports are all there for various things that we do later. But we go in here, I load a template. That template file is just some very basic HTML that gets passed in. We'll get to that in a second. Set count to a couple of different things, just preset them to false. I use them later for stuff. I originally did one data point, but then I thought it would be cool just to have multiple data points. You'll see when you actually see this, you're like, oh, that looks like crap. I agree. There's probably a better way to view that data. You'll see airplanes that are in like line of 3. It's because I've collected 3 collections of it. And you can tell that it's the same airplane because it's all traveling the same direction and they're all pointing the same way. Some we don't actually have the direction, so they're pointing up even though they're going this way. It can all be cleaned up. I think over time, like I would probably change it that instead of essentially the first collection, have the airplane icon, but then have just like a dot and like connect the dots. That's what the PyAware UI does. I just didn't do that. You'll see. So we get all that information. We pull out of S3. We get the objects of whenever they were last modified. So we want the last modification. So like I said, it's collected every 30 seconds. So we go somewhere between now and 30 seconds ago to get that the last collection, and then between 30 seconds and 60 seconds we get that collection, and then between 60 and 90 we get that third collection. Funny thing is, I found a bug while writing this talk. If you go to the URL at the top of the hour, it breaks because it's not smart enough to collect 30 seconds ago and then more than a minute ago is the hour previous. So it returns an error. So you have to wait like a minute and 30 seconds, and then you'll be able to see stuff again.
We got a library for you there. You can use
Oh, I'm sure. Yeah. Trust me. I'm presenting this purely because I know after the talk, we're going to figure out how to make it a little bit better. All that data gets collected. I pass it in to actually render it. I pass in a bunch of things. Like I'm using Mapbox to make the pretty UI. It's cheap and free. I'll probably have to update my Mapbox token after this talk because that is definitely seeable in here if I click the wrong page. Yeah, because you can see it right there. I'm not going to click it, but it's there. Let's see. Render all that HTML, send it through. Yep.
What are you rendering with? Is that Jinja?
Yep. Jinja template. We get down. So yeah, so these are all the pretty much the same function, just with last modified, second last modified, third last modified. Obviously, it could be condensed into a single function that takes in which iteration we want to get. It could even, once we did that, it would be easy to add in like a fourth last modified, go back as far back as the plane came into existence. We could probably render all of the data going all the way back to 2018. That's when it would start costing me some money. Lambda would probably not survive. There's some other stuff in here where we just, a very simple function of saying, okay, we have the key location that we want. Let's go out to AWS to S3 and actually pull that. Obviously, like a bad person, I'm hard coding the actual bucket name in there, but whatever. Don't do that. I did it. I get the plane count because I think initially, before I actually started displaying it, I just wanted to show how many planes were in the air. I don't actually show that anymore. Actually, if you slowly load the page, like if you pass it through like one of Chrome's dev tools where it says, induce some time into the system, you'll actually see it render total plane count 140, and then the actual image shows up. It's just because I'm lazy, I didn't delete the old code. This is, to actually render that stuff, I had to do some creating of the actual dictionaries of the latitude and longitude of the aircraft, which is it's just one of the pieces of information that's in there, the flight name, and the direction that it's heading. All that's very useful, partly because, like you saw, you don't always have that information, so I drop any aircraft that we don't actually have the latitude and longitude of. I just don't plot it. We're collecting information from it. It just may not be giving us the full message, and we just might not know where it's located. This is a pretty simple function that just says, okay, here is the actual features that we're going to display on this. So Mapbox wants, I guess it's not Mapbox, JavaScript to display these things properly, want a array, a list of features that get displayed on this. We're creating that information for the JavaScript later to say, here's your list of features. It's all of these latitude and longitudes. We give them a specific title and the specific rotation that they're supposed to display at, as the title is the flight name, and then the rotation or the direction of where it's going in the 360 degrees of its heading. Again, we don't always have that heading, and I don't know that I'm always passing it right, because you'll see a lot of these planes are actually pointing straight, and they may be going west. It's dumb. I'll fix it someday. But, I mean, that's 110 lines of Python to what you'll see is it displays some pretty cool stuff. This is the actual index HTML. This is that template. So, like I said, shows the number of planes, and then it actually goes out to Mapbox and creates that layer. I just have it centered over top of Frederick because that's where we're at. Loads up the, I pull up some images from, I think in the top one there is actually just a Wikimedia airplane at 25 pixels for the first layer, and then 20 pixels for the second layer, and then 15 pixels for the third layer, just to show the age of it. I could totally make it just a dot and then connect them. Just haven't done it yet. But it passes in the latitudes and longitudes of all the different features, and it displays it. So that's pretty it. Let me actually talk about the serverless one here, the serverless YAML, just to explain that. So this is actually what's telling serverless the thing, the application to how to deploy it. I updated this. I meant to remove this before the talk. It's just commenting out that we're obviously using the new format of IAM roles, but using least privileges, I've set that it can only get the bucket information from the actual S3 bucket that I have. I don't want anybody else, I don't want it reaching out into any other buckets because I'm paranoid. And then through serverless, you can actually have it set up a HTTP event, and then what it does is it actually creates the API gateway for you automatically. So I don't have to write any code, I don't have to write any CloudFormation or Terraform to create the API gateway. It does it for me just by adding in that part there. You can do a whole slew of other things. I only just cared that you can actually connect to it, so I have just the any/. There's copious amounts of other things that you could append to that to pass it through Cognito authentication or any other crazy stuff. I don't care about that. So I could probably do a deployment, and then you can see, because I want to, we'll do that. So very simple, just doing something like a serverless. Let me make sure, I'm still there. So serverless deploy. It'll probably fail because there's no changes. It'll probably come back and say there's no changes. It might push out a package. Hopefully it pushes out the package so we can actually see. Yeah, cool. So it created this endpoint for us. Anybody that has that endpoint can use it. And you get to see the airplanes overhead. Frederick. So you saw that just display real quickly, the number of planes. But we zoom in. It's aware of the density of the icons, so you only see 4, but as we zoom in, we see more and more. You start seeing the size of the icons change, so we're actually seeing the directions that they're going. So like Forge 94, that's an actual airplane overhead. We could look up Forge 94, who knows what it is. Let's see if we can type in probably some pretty, unknown owner. That's exciting. Position only flight. So this is, someone owns this airplane called Forge 94. They've actually contacted FlightAware to not retain their data. You can do that. You can contact FlightAware and say you don't want them to keep your data. They will purge it. But when you're in flight, they will keep a position on you. And obviously, my Raspberry Pi is adding some of that information. So we see it out there. That's a bad example because we don't have an actual direction for them, but here's a good one here. SWA 5405, that's the Southwest Airlines flight that's currently over Centerville and has probably taken off from, no, it's probably flying overhead. It's probably flying somewhere down south. But like this is exactly what I wanted to be able to do. I wanted to display the data somewhere outside of my house so I didn't have my Raspberry Pi exposed to the public internet. And I'm able to display the data. So much more I can do with it. Obviously, I can make it a lot more pretty, but it works.
It's pretty slick.
Yeah. It's all served in Python too. Like I said, it's a JavaScript template, but the actual execution is Python, and it runs every single time I click that. So we can actually click it a bunch of times, and then let's go check out CloudWatch. We can actually see, I probably want to go to Lambda. I'm probably the only person that's executed that today because nobody else knows what the URL is.
Now, is API Gateway a required element of this in order to make HTTP to Lambda?
That's what I didn't realize was the actual API gateway is the thing that's returning the HTML. The Lambda you can get the HTML out of Lambda, but you can't render that into anything. The API gateway is the thing that's sending the rendered HTML to you. Well, I can show you that because we'll test it in Lambda. You'll see that it does return HTML, but you have no way to interface with the Lambda to be able to render that HTML.
The API gateway is serving as your internet endpoint. The Lambda function is your back end.
Yeah, so
So it's just delivering off the bytes.
yeah, we see here's my invocations there. It's just returning that. If we go to test it, I can just hit the test here, and it sends back rendered HTML, but it's as the body, and it returns the event. That's an event to API Gateway. API Gateway gets that and says, oh, I know what to do with that. I take the body and I send that to the person that requested it.
Cool.
Oh, and there's my Mapbox token. So that's the thing that I think actually probably doesn't matter because you have to display that.
Anyway.
Yeah.
Yeah.
So
Not
enjoy.
really private.
Yeah. So yeah, that's what that's what I did. I wanted to get my plane data out of my house, and 100 lines of Python and some pretty simple AWS knowledge. I didn't have to expose a Raspberry Pi to the public internet. Well worth the time investment, because you put that Raspberry Pi on the internet, somebody's going to screw it up.
Yeah.
So yeah, that's it.
Have you shared this project with other Skyware users, like anybody else that?
I've met one other Pi-aware person, and
It'd be pretty sweet if there were like collections, like somebody in Arizona.
So,
their
I was briefly very interested in trying to have multiple Pi-awares out there. I actually had a buddy of mine run one and send it to this S3 bucket for a while. He got out of it, but yeah, he only did it in 2018 for 2 months. But it would be entirely possible to make S3 the collection point for this, right? And you could just have these all over the United States from various people just sending it there. And then if you've got it displayed properly, you could see all the planes all over it. I mean, that's kind of what they're doing with FlightAware. Like you can see the real-time worldwide traffic.
So FlightAware is a company. Is there an open source thing that can also parse the signal stuff that comes off? Because it sounds like FlightAware is doing the work to package that up.
Yeah, they are with their Pi-aware. I don't know that there's anybody else that has done kind of the same thing. They make it available to you on your device. I don't know that they've said anything about not saying, hey, I can't make a copy of this. No, it's my data. I'm giving it to them. I just use their open source. It is open source application running on a Raspberry Pi. They're using, I forget the name of the actual. I think it's called Dump 1090 is the application. They actually use Dump 1090 to pull the ASDB data. They use Dump 1090 to pull that data and put it into a format that they then put a web server around, and then also a thing that publishes to them. So they have some open source applications that they're using, which is probably why they don't care that you can pull the data yourself, because it's open source. I mean, it's radio waves.
So 1090 is probably some binary format that Dump 1090 parses and
Correct.
repackages.
Which is why you get some of those partial messages, which is super fascinating to me. Like that one message I was looking at where That's not, we're not gonna see it, but one of these, like this one, like this message here is not a full message because we collected something, but we don't have a position, we don't have a direction. We're missing some stuff. Either it's not broadcasting that information, or more likely, we just didn't capture what that full message was. So, yeah, that's very, very simple little Python display. I like it because, like I said, it costs nothing unless thousands of people go to it. Yeah. All right.
Cool. Well, thanks, Patrick.
Thanks.
You guys have any questions?
What do you do with the JavaScript, or how do you pull it into the web browser?
So, like, how does it get rendered?
Yeah.
So that all gets passed through this response that the lambda sends back. It includes it in that body, and the API gateway renders based off of that body there, renders the actual HTML and sends it over to the receiver.
I think what I saw is in your handler code, you built up the dictionary, the data structure
Yeah.
of all of, what was it, fields or, no, that wasn't features.
Yeah.
So features were the things that then was a structure that got rendered into the template itself. And that template appeared to be doing the JavaScript call here.
Yeah.
Like
So
old lat longs there or something,
Right.
kind of rendering it directly.
So we render a map. It loads the image, like that top image is the feature collection. That's that GeoJSON right there of feature collections with the lat longs of features. And so it's taking in, it says, okay, I'm going to create this image, and that image is going to be these 25 pixel plane icons, and it's going to create a plane icon at every lat long feature in that list of lat longs. And then we do each after that, we do another one, but with a smaller icon, another set of lat longs, and then a third set at that 15 pixel at another set of lat longs. I'm very confident there's a cleaner way to do it, but yeah.
Cool. Which part is kind of where you have the larger planes as you're zoomed out, and then
That, I don't, so I'm going to answer that with, I don't actually know. That is from my understanding, that is actually a feature of either how I'm rendering it in JavaScript or like how the Mapbox interface is working. It's saying, I can't display those, all hundreds of those planes in that area. So it condenses it and says, I'm only going to display these to show the user that there's something there. I mean, you can see here, there's even airplanes that are that we get a 000 on. So they show up at 0 latitude, longitude, right?
Oh, is that, oh, yeah,
Yeah. Yeah. But yeah, so that's not anything I'm doing. That's the built-in thing. It's doing that for me, which is really nice. I assume it helps with rendering, it helps with page loading. Like there's a whole slew of things that it's doing to just make that an easier.
Yeah, it didn't seem like there were any like conflicts between that, so there must be some spacing logic of
Yeah.
figuring that out too. It's pretty cool.
Yeah.
do you do any other like radio projects?
I haven't recently. So along with ADSB, there's a radio frequency that the airplanes broadcast that's actually like plain text. I forget what frequency it's on, but you can pick that up as well. And I've toyed with the idea of like having a stock ticker that just is broadcasting what like pilots are saying to each other.
Oh, is that what it is?
Yeah. It's a lot of times it's either like a flight dispatch talking to a pilot, or pilots talking to each other.
So it's like CB radio for airplanes.
Well, it's not even CB. It's text based. And I watched this one pilot. His name's he's on YouTube as 47 gear or something like that. 47 gear. He's a 747 long haul pilot. He doesn't really fly people. He flies cargo, and then he flies, I think, for Boeing a lot to like deliver aircraft. And he was saying like that's really all they talk over now is they'll send messages to each other over that system instead of calling over the radio, because there's so much traffic out there now that it would just be constant radio communications. So they just, if it's something simple, like they're just checking in with if they're let's say you're a plane flying from JFK to Dulles, and you're on getting ready to be on final approach or whatever. I don't know all the terms there, but they will send the message to the air traffic control, like saying, hey, we're on our way, we're getting in this location, tell me what frequency I'm supposed to be on or whatever. And air traffic control will respond over that instead of calling them up on the radio and saying, hey, here's your frequencies. Just because it keeps the channel clear for more important things like emergencies. But I thought about doing that just because it's all text,
Yeah.
and you could totally have a website that's just constantly throwing up those messages.
Yeah, that's super cool. Is that something that like FlightAware has an interface for, or you'd have to like pull through it?
I forget, I could do some Googling and find out what the actual protocol is. Just like that dump 1090, there's an open source project that lets you display that stuff as well. But you have to have a different, so ADSB is on 1090 megahertz. That other frequency we're talking about, or that other protocol, is actually, it depends. Like Delta has their own set of frequencies, Southwest has their own set of frequencies, and that's what they're all listening to each other on. If you were playing, like if you were trying to pull that data, you have to pre-program into it what frequencies to listen on, and then it's essentially in ASCII text broadcast.
I can just imagine you using like the marquee tag to have like old school text going across on a website. That'd be epic.
Yeah. I told you I like weird data. Like this is constantly broadcasted out there. It's just out there constantly, and you can pick it up and throw it out onto a stupid website.
It's a pretty fun random set.
Yeah.
That's cool, man. This is neat.
You too can collect this.
Think about it.
It's like not even $100 to build the stuff out. I closed out the window. I think the Raspberry Pi was $35. The dongle and the filter and the antenna, like in total, was $75 in total for the entire thing.
It's not bad.
And it's been running since then. Occasionally it goes down. I got to reset it, but it works.